Now that you've been introduced to the different characteristics of connective tissue, it's time to start talking about the different actual connective tissues. And we'll start by looking at what are termed connective tissue proper. So, as we said before, connective tissues are distinguished or composed of cells surrounded by non-living extracellular matrix, and they include a specialized cell or cells, some type of protein fiber or fibers, and then the ground substance. And so what distinguishes each of the connective tissues from each other are the types of specialized cells that are found there and the types and proportions of each of the fiber types. And so we'll be starting by looking at first the connective tissue proper, which include the loose connective tissues, which are primarily ground substance with cells and fibers interspersed, and the dense connective tissues, which are mostly fibers with very little ground substance and cells that hang out in between the fibers. In another lecture, we'll be looking at the specialized connective tissues, but for right now, we're going to just stick to the connective tissue proper. And I believe that, the way I understand this term proper here is that it's talking about the connective tissues that actually have one of those connecting functions. So as we look at them, look to see what it is that's being connected by the tissues. The first that we're going to discuss is areolar tissue. And in areolar tissue, the fibroblasts are the most abundant of the cell types. And you can see, and when you look at these under the microscope yourself, you'll be able to see the fibroblasts, and they'll be distinguished by the nuclei kind of hanging out. And so in this connective tissue, we see the fibroblasts as the most abundant cell type. The ground substance is gel-like, so it's not a real loose fluid ground substance. And the primary fibers that we see are collagenous and elastic fibers. And so you can make out the collagenous fibers. Here's one extending along there. They stain kind of light purple. Here's another. And they tend to be located not in regular bands, but they go in all directions. So here are more collagenous fibers. This is a really big, broad one that then kind of splays out. Here's another collagenous fiber kind of making its way. So notice they're just at all crazy angles to each other. And then interspersed are the darker staining elastic fibers. So here's an elastic fiber. Here's another one. Here's a third. So we've got these darker staining elastic fibers. And so between the two fibers, this is a strong tissue. It's got a lot. It resists being pulled too much. And it's also nice and, just a little stretchy. So it's got a stretchy component to it as well. And we seek areolar tissues binding the skin to the underlying organs, primarily to the muscles, and that's and it is the subcutaneous layer. So that's another term for the areolar tissue that's underneath the skin is the subcutaneous, and it fills spaces within muscles. So where muscles are, we find connective tissues, this areolar tissue, kind of filling in the space. And underneath most epithelial layers, areolar tissue is what you're going to be seeing. All right, so that's areolar tissue. The next one to talk about is adipose tissue. In adipose tissue, it's the adipocytes that are the most common of the cell types. Adipocytes here. And this is an adipocyte. This is, let's see, we would include that much. Let's see if I can do a better job drawing. My pen doesn't let me draw exactly. But these are the adipocytes. And cells in adipose tissue initially resemble fibroblasts. But as the body takes in more energy than it can store in the liver in the form of glycogen, then that extra energy is converted into fat, and the adipocytes will pick up that fat and store it in their cells as a fat droplet. So this area here, I'm going to lightly shade it. That's where the fat droplet is. And the fat droplet can become so large that all of the organelles get squeezed off to the side. So there's a nucleus in this particular adipocyte. So the nucleus, the organelles, they're all squeezed over into this little corner, and the bulk of the cell is made up of the adipocyte. I'm sorry, of the fat droplet. So once we convert a fibroblast to an adipocyte, so once an adipocyte is made, it never goes away. It always remains there as an adipocyte. And as a person gains or loses fat weight, then that droplet, it merely increases and decreases in size. So once there, always there. So areolar tissue can convert to adipose tissue if too much energy is consumed, more than can be stored in the liver. So the functions of adipose tissue are to store energy. That's the primary function. But it also serves as insulation against shock and against temperature change. So it has a real insulating quality as well. And we find adipose tissue beneath the skin. So found under the skin, where that areolar tissue has converted into the adipose tissue under skin. So it's found under the skin, in the abdominal membranes, which is why people put on fat in their bellies. So in the abdominal membranes, it's in joints, where it cushions the joints. We find fatty pads. And around the kidneys. Remember, the kidneys are retroperitoneal, and so that means that they don't have any of the protections offered by the serous membranes of the abdominal pelvic cavity. And so it provides cushioning, adipose tissue does, for those for the kidneys there. The last kind of loose connective tissue is called reticular connective tissue, and the primary cell are fibroblasts, and the primary fiber in reticular tissues are the reticular fibers. And so these reticular fibers, remember, they branch. Here we can see the branching of the reticular fibers. And they form kind of a supportive framework for the cells that are found in the tissues that they're helping to create. And so we see reticular tissue in the liver, the spleen, in bone marrow, and inside lymph nodes, where it provides the framework. And if you've ever cooked with liver, you know it has a really very particular kind of spongy texture, and that is provided by those reticular fibers. So there's a real characteristic texture, almost, I guess I could say, to tissues that are built of reticular fibers. Okay, so those are the three loose connective tissues, and we're going to look now at the dense connective tissues. Dense connective tissues, I want to remind you, they've got a high density of protein fibers in relation to the amount of ground substance. You can see that the protein fibers in the loose connective tissues, there's lots of space between them. We don't see that in dense connective tissues. And there are three subtypes of dense connective tissues as well. The first one we'll look at is dense regular connective tissue. So here's a dense regular connective tissue. These are the protein fibers. And they have like a little bit of a bend to them. cause them to be slightly stretchy, but the dense regular connective tissues are composed of very densely packed collagenous fibers, and they're arranged in parallel to each other. And then there's a very fine network of elastic fibers that also gives a little bit of a springiness to the dense regular connective tissues. And relatively speaking, there are relatively few fibroblasts. These are the nuclei of the fibroblasts. And they're packed in between, or sandwiched in between the collagenous fibers. And so they tend to the fibers, and as the fibers get damaged, these guys are responsible for repairing the damaged fibers. So dense regular connective tissue is what makes up tendons and ligaments. Tendons and ligaments are built of dense regular connective tissue, and they're very strong. You can pull in opposite directions here without breaking tendons very easily. So hard pulls, and they can still withstand that. But it turns out that if you pull a tendon or a muscle opposite, at 90 degrees to the grain of that tendon, then you can damage it. And once damaged, because there's just not very much in the way of blood vessels in dense regular connective tissues, once damaged, they can be very slow to mend. Anybody who's ever had like a tendon tear knows that it takes forever for them to get better. Okay, so dense regular connective tissues. The connective tissue may be a dense irregular connective tissue. So in that case, it's still built of closely packed collagenous fibers, but they're interwoven in much more irregular ways. So here are the collagenous fibers in an irregular connective tissue. So the fibroblasts are found amongst all of these fibers, and their job again is to tend to the fibers, repairing them should they become damaged. But because we have all of these fibers running in all different directions, dense irregular connective tissues can withstand being pulled in these directions or in this direction. So here are some fibers that are going to help to resist being pulled in that direction. These fibers here help to resist when we pull in opposite directions this way, and so on. So no matter which way you pull a dense irregular connective tissue, there are going to be fibers there in that laying in that line of pull to resist the stress. And so we find dense irregular connective tissues in the dermis just below, and that's what we're looking at here with this picture. So here is the epidermal layers, here's the dermis, and it's composed primarily of this dense irregular connective tissue. In the fibrous coverings of bones and kidneys and the lymph nodes as well, and in the material that covers and encloses the joint capsules. So we see dense irregular connective tissues in places where the pull is going to come from a whole bunch of different angles. All right, so our third irregular connective tissue, our third dense connective tissue is called elastic connective tissue. And elastic connective tissue, as the name might suggest, is composed primarily of those yellow elastic fibers. And they're arranged in these kind of parallel-ish strands. And here it is. This is relaxed elastic connective tissue. But when you pull on it, it can stretch, and then it snaps back to its original shape. And so we find these elastic connective tissues in areas that need to be both strong and elastic. So at the aorta, that's the main vessel leaving the heart, which has to withstand a fair bit of very intense blood pressure. In the trachea, where we have to maintain the trachea open, and in between the vertebra, we'll see some of this elastic connective tissue as well. All right, so those are the three types of dense connective tissues, three types of loose connective tissues. With the loose connective tissues, we have areolar tissue and adipose tissue, and the last kind is reticular connective tissue. And then we have the three types of dense connective tissues: dense regular, dense irregular, and elastic connective tissues. Okay, so that's it for the connective tissue proper, and our next talk will be looking at the specialized connective tissues.